Good morning friends. Now we are discussing Bernoulli's equation in module number 3, fluid dynamics of the subject fluid mechanics. So derive Euler's equation of motion along the streamline. Obtain Bernoulli's equation using the reduced Euler's equation. So to derive Euler's equation of motion, we consider a fluid element of length ds and the cross-sectional area dA. So the fluid flow is taking place in the S direction. The weight of the element W is making an angle theta with S direction. So weight density is rho g. So weight density is equal to weight by volume. So my weight is weight density into volume. So weight density is rho g. Volume of the fluid element is dA into ds. Area of the element dA multiplied by length of the element ds. So it gives volume of the element. So weight is nothing but the product of weight density rho g into volume of the element, that is dA ds. We have W making an angle theta. So splitting inclined force into its x component and y component. So the x component is W cos theta, y component is W sin theta. So we have P, the pressure at the beginning of the element. So we have the pressure force. So pressure into area. So P dA. Then we have the rate of change of pressure as we move 1 unit of distance we travel. So dou P by dou S. So ds is the actual length of the fluid element. Now, so we know the total change in the pressure, that is the rate of change of pressure is nothing but dou P by dou S into ds. So change in the pressure P with respect to the distance travel by 1 meter or 1 unit of length. So total change in the pressure is dou P by dou S into length of the fluid element. So that is ds. So we have, so if we know how much the pressure changes per 1 meter length, that is the rate at which the pressure is changed, and you know how many meters long the fluid element is moved, the distance traveled. So total change is nothing but dou P by dou S of ds. So pressure at the exit is actual pressure P plus change in the pressure, that is dou P by dou S of ds. So we have the three forces acting on the fluid element. So that is shown in the beginning. So that is pressure force at the entrance P into dA. Pressure force at the exit against the flow P plus del P by del S of ds into dA, and the weight W. So it is to be splitted into x and y component. W cos theta is the component of weight in the S direction. So we have three forces acting on the fluid element. So pressure force in the flow direction, pressure force against the flow, and weight of the element. Now we know that the summation of all the three forces, one is going to the right, that carries plus sign, the other two are going to the left, that carries minus sign. We take the summation of all the forces made equal to m into a, that is force is equal to mass into acceleration. The summation of forces made equal to the product of mass into acceleration. So now we have summation of forces that will be equal to mass. Now mass is nothing but density into volume, because we know that density is the ratio of mass by volume. So my mass is density into volume. So density is rho, volume is dA ds. In earlier, for weight density we have taken So here we have taken the weight density as rho into g. So weight is nothing but weight density into volume. So in mass density we have only rho. No g is there in the picture. So we have only we have rho dA ds, that is my mass, and acceleration is given as v into dou v by dou s, that is from chain rule of differentiation. So we know that acceleration is change in velocity with respect to time, dv by dt. Using chain rule of differentiation we write it as dou v by dou s of ds by dt. So since we know that ds by dt, that is speed with respect to time, ds by dt is nothing but my velocity. So substituting ds by dt as velocity into dv by ds. So substituting AV and dividing both sides by rho dA ds, we have the equation written at the bottom. But we know that cos theta is adjacent side dz by hypotenuse ds. So in place of dz we are writing ds cos theta. So in place of cos theta. So we have dz is equal to ds cos theta. So and simplifying the equation, we get del p by rho plus g dz plus v dv is equal to 0. That is Euler's equation of motion. So on integrating, so taking density g outside the integration, we have p by rho plus gz plus v square by 2, that is equal to constant. Divide both sides by g, we have Bernoulli's equation, where p by rho g is pressure head, v square by 2g is velocity head, z is datum head. Thank you, friends.